My name is Hugo, and I'll be your host for Introduction to Python for Data Science. I'm a data scientist and educator at Datacamp, and host of the Data Frame podcast, which you must check out. In this course, you will learn Python for data science through video lessons like this one and interactive exercises. You get your own Python session where you can experiment and try to come up with the correct code to solve the instructions. You're learning by doing while receiving customized and instant feedback on your work. Python was conceived by Guido van Rossum. Here, you can see a photo of me with Guido. What started as a hobby project soon became a general-purpose programming language. Nowadays, you can use Python to build practically any piece of software. But how did this happen? Well, first of all, Python is open source. It's free to use. Second, it's very easy to build packages in Python, which is code that you can share with other people to solve specific problems. Throughout time, more and more of these packages specifically built for data science are being developed. Suppose you want to make some fancy visualizations of your company's sales. There's a package for that. Or what about connecting to a database to analyze sensor measurements? There's also a package for that. People often refer to Python as the Swiss Army knife of programming languages, as you can do almost anything with it. In this course, we'll start to build up your data science coding skills bit by bit, so make sure to stick around to see how powerful the language can be. Our courses focus on Python 3. To install Python 3 on your own system, follow the steps at this URL. Now that you're all eyes and ears for Python, let's start experimenting. I'll start with the Python shell, a place where you can type Python code and immediately see the results. In Datacamp's exercise interface, this shell is embedded here. Let's start off simple and use Python as a calculator. Let me type 4 plus 5 and hit enter. Python interprets what you type and prints the result of your calculation, 9. The Python shell that's used here is actually not the original one. We're using IPython, short for interactive Python, which is some kind of juiced up version of regular Python that'll be useful later on. IPython was created by Fernando Perez and is part of the broader Jupyter ecosystem. Apart from interactively working with Python, you can also have Python run so-called Python scripts. These Python scripts are simply text files with the extension .py. It's basically a list of Python commands that are executed almost as if you were typing the commands in the shell yourself, line by line. Let's put the command from before in a script now, which can be found here in Datacamp's interface. The next step is executing the script by clicking Submit Answer. If you execute this script in the Datacamp interface, there's nothing in the output pane. That's because you have to explicitly use print inside scripts if you want to generate output during execution. Let's wrap our previous calculation in a print call and rerun the script. This time, the same output as before is generated. Great. Putting your code in Python scripts instead of manually retyping every step interactively will help you to keep structure and avoid retyping everything over and over. Will help you to keep structure and avoid retyping everything over and over again if you want to make a change. You simply make the change in the script and rerun the entire thing. Now that you've got an idea about different ways of working with Python, I suggest you head over to the exercises. Use the IPython shell for experimentation and use the Python script editor to code the actual answer. If you click Submit Answer, your script will be executed and checked for correctness. Get coding and don't forget to have fun.
Hit run code to refresh. Finally, and see the output. Notice the script without EP Wi-Fi notice where you can type that stuff. Okay. Wait, what? Oh,
Well done and welcome back. It's clear that Python is a great calculator. If you want to do more complex calculations, though, you will want to save values while you're coding along. You can do this by defining a variable with a specific case-sensitive name. Once you create or declare such a variable, you can later call up its value by typing the variable name. Suppose you measure your height and weight in metric units. You're 1.79 meters tall and weigh 68.7 kilograms. You can assign these values to two variables named height and weight with an equal sign. If you now type the name of the variable height, Python looks for the variable name, retrieves its value, and prints it out. Let's now calculate the body mass index, or BMI, which is calculated as follows, with weight in kilograms and height in meters. You can do this with the actual values, but you can just as well use the variable's height and weight, like here. Every time you type the variable's name, you're asking Python to reference the actual value of the variable. Weight corresponds to 68.7 and height to 1.79. Finally, this version has Python store the result in a new variable, BMI. BMI now contains the same value as the one you calculated earlier. In Python, variables are used all the time. They help to make your code reproducible. Suppose the code to create the height, weight, and BMI variables are in a script like this. If you now want to recalculate the BMI for another weight, you can simply change the declaration of the weight variable and rerun the script. The BMI changes accordingly because the value of the variable weight has changed as well. So far, we've only worked with numerical values, such as height and weight. In Python, these numbers all have a specific type. You can check out the type of a value with the type function. To see the type of our BMI value, simply write type and then BMI inside parentheses. You can see that it's a float, which is Python's way of representing a real number. So a number which can have both an integer part and a fractional part. Python also has a type for integers, int, like this example. To do data science, you'll need more than ints and floats though. Python features tons of other data types. The most common ones are strings and booleans. A string is Python's way to represent text. You can use both double and single quotes to build a string, as you can see from these examples. If you print the type of the last variable here, you see that it's str, short for string. The boolean is a type that can either be true or false. You can think of this as yes and no in everyday language. Booleans will be very useful in the future to perform filtering operations on your data, for example. There's something special about Python data types. Have a look at this line of code that sums two integers, and then this line of code that sums two strings. For the integers, the values were summed. While for the strings were pasted together. The plus operator behaved differently for different data types. This is a general principle. How the code behaves depends on the types you're working with. In the exercises that follow, you'll create your first variables and experiment with some of Python's data types. I'll see you in the next video to explain all about lists. Let's get you coding. And I can't wait to see you in the next chapter, where you'll build even more awesome Python jobs.
Seems to In the previous exercise, you worked with the integer Python data in type int or integer, fractional savings with a value of 100 as an example of integer. These are common float, string, and boolean. Create a new float half with Find out the type of data returns the value. You can use a type function. Suppose you're using to find a variable, but you got the type of this variable. Determine the type A, simply execute head when created date. You can use Python to get one type. This type. Okay. Oh, that's cool. Lay back and boolean. Okay, so it is the float, flow string. You could mention that different types behave differently in Python when you num some tutoring, for example. In the script, some variables with different types have already been created. It's up to you to use them, calculate the in your savings. Winning idea. Oh, unexpected ended. Mm. Simply send a message as int float input will help you convert any data type. Okay, so you can only concatenate like string, not int to string, into string. You can only, so it's basically use the functions to convert the variable savings into. Now that you know something more about combining two different sources of information, have a look at board expression, Python expressions below. Which one of these will throw out an error? You can always copy and paste the code in the Python shell to find out. I mean, you can never be too sure. I just want to make sure that I believe it's going to be this because it's not defining two as like a string. So let's see. Yep. Okay. I was just making sure. So, thank you. So apparently I am done with this course. The reason why I fast forwarded the video was because it was like pretty straightforward. So I knew the basics from the start, but when it comes to like coding overall, like it just gets very like complicated for me because if it's like if it's a problem with complicated tasks, then I would struggle with it a bit. But then when it comes to the basics, I wouldn't be able to struggle too much. And that's why I fast forwarded because it's like super common knowledge now with but then when it comes to the complicated advanced side of programming, I guess like I actually need time to review like yeah, so I guess I'm done with this video. I'm so sorry. This was shorter than I expected compared to other videos. So yeah. And here's my proof that, I can't, I even would have tried to do the free trial too. Yeah, if that's possible. Yeah, so I tried pausing it in between and see if there's any free trials that I could do, like to at least meet the 1 hour requirement, but I can't do anything about it. So sorry about that.